In this video, we'll be looking at how to find the ratio for a closed system input-output model. Now, we know this is a closed system as opposed to an open system because if we look at the matrix, we see that the columns all add up to the number 1. Now, what each column means is what is required to produce 1 unit of whatever this commodity is. So if it costs 1 unit to produce 1 unit, then we break even. So this is how a closed system works. Everything that is produced is consumed in the process. And so the equation that we use for any input-output system is x minus ax equals d, where x is how much is produced, ax is how much is consumed, and d is what is left over. So it's kind of like a profit equation. How much you make minus how much you spend equals what's left over. Now in a closed system, everything that we make is consumed in the process. So when we subtract x minus ax, we're going to end up with 0, because 0 is what's left over if everything is consumed. And so what we'll do here to simplify this equation is we're going to factor out an x, since both of these terms have an x. So that will leave us with I minus a. And then since the x is on the right-hand side of this a, it needs to go on the right-hand side here, and that's going to equal 0. And so this is the equation that we're going to use for a closed system input-output model. So the first thing we want to do is put matrix A into our calculator. And so I already have that in this calculator. So we go second matrix, over to edit. We put this in matrix A right there. So now that we have that, we have our matrix A, what we now need is matrix I. And so our calculator has a function for that. I is the identity matrix. And so what we'll do is go second matrix. We'll go over to math. Actually, we need to quit first. Second matrix, over to math, down to identity. And we'll do identity 3. Because we want a 3 by 3 identity matrix. And so we want it to be the same size as whatever A is. A is 3 by 3. We only need to put one number 3 in the identity function because identities are always square. So we put 3 there, it's automatically going to be 3 by 3. So we have identity 3, we're going to subtract matrix A. And so what we get is this right here. Now, what we have here is really the beginning of a system of linear equations. It's just the left-hand side of a system of linear equations. So that first row there would say 0.8x minus 0.3y minus 0.2z, but it doesn't have what it's equal to. So what we need to be able to solve this linear system of equations is what it's equal to. And we can use the equation above. We see that it should be equal to 0. And so what we want to do is we want to go in and add a column of zeros because each of these equations here should equal 0. So what we're going to do is we're going to store this matrix. So we'll use the STO button down at the bottom of our calculator. We'll go second and then matrix, and then I'm going to store it as matrix B. All right, so now we have that matrix as matrix B, so now what we're going to do is go in and edit that matrix. So we'll hit second and then matrix, go over to edit, down to matrix B. So matrix B is a 3 by 3. What we want to do is make it a 3 by 4. And so now what we have, we look at this top row, that's 0.8x minus 0.3y minus 0.2z equals 0. So we have our entire equation for that top row as well as for rows 2 and 3 as well. So now that we have our full system of linear equations, we can solve for it. And we'll do that the same way we've done in the past. We'll use the RREF function, reduced row echelon form. So to do that, we'll hit second and then matrix, go over to math, go down to RREF, select that, and then select matrix B. And we're always going to get some decimals here, and so if we hit the math button and then select fraction, we get some more manageable fractions. All right, so now what we want to do is we want to take this matrix and we want to write each of these rows out as an equation. So that first row over here is 1x, so we'll just write x, plus 0y, so we don't need to write that, minus 10/13 z equals 0. The second row is 0x plus 1y minus 18/13 z equals 0. And then the bottom equation is just 0 equals 0. Now, anytime we have a row of zeros across the bottom, what that tells us is that we have an infinite number of solutions, which you'll always have for a closed system input-output matrix. So what we want to do now is take each of these and solve for z. So for this first equation, we would add 10/13 z to both sides. So that's going to give us x equals 10/13 z. And then for our second equation, we're going to add 8/13 z to both sides. So that's going to give us y equals 18/13 z. And then we don't have a third equation, but we really know that z equals z, because that's obvious. So now we have everything in terms of z. We have x equals something z, y equals something z, and z equals something z. All right, so what we want to do now is create a ratio out of this. And so the ratio of x to y to z would be 10/13 to 18/13 to 1, just using the coefficients in front of each of these z's. Now, the way ratios should be written is as whole numbers. So it doesn't really work like this as fractions. So our last step is we want to multiply through by something that'll make all of these whole numbers. And so the easiest number here is 13. If we multiply everything by 13, that's going to clear out our denominator here. And so we multiply 13 all the way through, that's going to give us 10 to 18 to 13. And that's going to be our ratio for this problem.